right, guys, we are going to fill in a request that many of you guys have, and that is, lots of you guys asked, we'd like to see more of the Trans Am that I affectionately refer to as Blackbird, my 2000 Trans Am WS6 that is rather significantly modified with 710 horsepower, dyno tested at the rear wheels. So we have a new issue that has developed. Once again, this has not been the best year for Blackbird. As many of you guys know who follow along on my paid content channel at www.schrodingersboxqm.com, we have featured Blackbird quite a bit with a few electrical problems, and also, of course, last year the rather scary cylinder head failure that we had to do extensive repair work on. Well, now we've got a new issue that happened. So just this morning, I was on my way to the car wash, actually, and without going into much detail, I maybe did something I should not have done. It involved a overly excessive acceleration event, I guess would be a way to put it without being too specific. And what ended up happening is things were going really good and really fun for a minute there, until I could feel the car lean out very dramatically. When the car leaned out, I of course let off and thought, well, you know, of course your mind is going to the worst possible thing, especially with, you know, cylinder head issues last year and all that. So drove the car off to a parking lot. It drove absolutely perfectly fine without any issue. Checked around, couldn't really find anything. And then drove it back home, doing a couple of other events to see if I could reproduce the condition, and I was able to. There was a definite feeling of leaning out under really heavy acceleration, but otherwise drove totally fine. So I thought it was going to be a really interesting video with something going on that we could do our typical diagnostics, but when I pulled the car into the garage and started setting up, I could absolutely smell fuel in the garage, and thus the reason I suspect we're going to find a fuel leak here. Of course, that begs the question, fuel leak is pretty simple. Why would we do it on an advanced diagnostics channel? Anybody can find a fuel leak. And the reason is because I thought it might be interesting because, first of all, many of you guys just want to see work on the car. And second, because the fuel system on this car is something that you're not typically going to run into with the types of connections and things like that. So there's a good chance that we may run into something with the diagnosis and repair that would not be a very familiar thing to you if you work on regular passenger cars. So that's kind of the theory here. I don't know what we're going to find, but I can tell you right now it smells like fuel in here. And you know, we're also going to do some precautions as well, because needless to say, I don't want to burn the house down doing this. I guess it might be of interest to you guys to also explain another difference with this fuel system we may not see, but it may be of interest to you, and that is with fuel systems in true high-performance cars. We're not talking about your guys with the Honda Civics and the Acuras and the Subarus with the fart can on it and everything. We're talking like when you're delivering 700, 1,000 horsepower to a car, you run into a very common situation. You will start having a fuel delivery problem. And as most people are familiar, very often you get high flow fuel injectors. So you get these fuel injectors that are capable of delivering a lot more fuel and everything. Well, the trouble is that that's not really so much often where the problem is. Where the problem is even if you have the high flow injectors, it's delivering enough fuel to those injectors that you can still maintain a rich condition under heavy throttle. That is the most important thing that you're going to run into when you get into this kind of high performance thing, is that you will find that the car starts running lean under heavy throttle, something most people aren't even aware of because they don't know how to determine that that's happening, right? But if you are running lean under heavy throttle, you are going to lose massive amounts of horsepower, and you're really not reaching near the full potential of the vehicle. So very often you need higher flow fuel pumps. This car has a setup where it's kind of in two stages, where you've got sort of a normal fuel pump activity when the car is under normal driving conditions, but then there's a trigger under wide open throttle that we key in a second activity to make sure that we maintain fuel pressure to keep that rich condition under wide open throttle. We may have an issue there. You know, that would be interesting if we find that. But in general, with the high performance vehicles, keeping that rich condition under wide open throttle. Some of the stupid things people will do is things like a EGR delete. They don't want the EGR on there because the EGR can lean out conditions. EGR is not used under wide open throttle, so you have no benefit in deleting that other than now you can't, you know, get your car to pass inspection, or you have a check engine light that you put tape over or whatever. So stupid things like that. As I mentioned, fuel injectors, putting high flow injectors into your car has absolutely no difference whatsoever. If the demand is met, you are not going to get extra fuel flow into the vehicle. That's not going to happen. So your high flow injectors are a waste of time unless you A, need them, and B, have the capacity to feed them in the first place. You can still run lean with your high flow injectors. Gosh, I'm trying to think of some of the other stupid things that I've seen over the years when I used to go to the racetrack and everything that people would do. But manipulations of the mass airflow sensor, things like that. Once you're running rich, any more excessive fuel really can actually start causing performance issues then, because you're flooding the cylinder. Also, needless to mention that if you're running rich all the time, you're going to start having troubles with your catalytic converters, and at best you'll just, you know, shorten the life of your cat. At worst, you start clogging the catalytic converter. Of course, clogged catalytic converter, restricted exhaust, massive horsepower loss. Anyway, a lot of you guys are interested in that stuff, but I'm kind of interested right now in fixing my car. So let's go ahead and take a look here. The first thing that I want to do is I want to confirm that we do have a fuel leak somewhere. And I think the easiest way to do that is we're going to connect up a fuel pressure gauge. Okay, I am no dummy. You guys who watch my channel have seen me complain ad nauseum about cars that do not have Schrader valves on the fuel system. I made sure I got a fuel system that has a Schrader valve. The first thing is we should have pressure here, so let me just check that real quick. And like I said, I checked everything. I don't see fuel leaking anywhere. I don't particularly smell fuel right now, but I do smell it in the garage, especially over on the left side of the engine where the fuel rail does go over the exhaust manifold for just a second there. We definitely don't want a leak of fuel on the exhaust manifold. That would be devastating. I'm just going to push in this Schrader valve real quick. Oh, there's pressure there. Okay, so we do have fuel pressure there. But the thing is that, you know, we're not quantitating it through putting a screwdriver on there. So we don't have a total leak down of the fuel pressure for sure. But my guess is that we're going to see evidence of a leak down. All right, we're going to set this gauge here, and let's take a look at it. Okay, what I want to do is a decay test. And a decay test is going to measure how quickly we lose pressure over a period of time. So what I'm going to do is just turn the key to on a couple times to get that fuel pump prime. I want to see probably 60 psi here, so I'm going to prime it a couple times. Can you hear the fuel pump runs really strong? And we've got pretty good fuel pressure there. While we're doing this, I'm looking around. I don't see any leaks anywhere. We are dropping pressure though. For sure we're dropping pressure. Let's take a look in here. This is in real time. And I am definitely not happy with that. Now it is possible. It is possible that the fuel leak can be internal, like a leaking fuel injector, something like that. You would definitely smell that for sure as well. But I would have expected with that I would have a little more dramatic engine performance issues, particularly with driving at the lower speeds. And I did not. I can tell you the car drove perfectly fine. Wow, look at that decay rate. We absolutely have either a check valve problem at the fuel pump, which of course would not cause external fuel smell, or we have an external leak on the engine, or we may have a combination of things. Yeah, that decay rate's pretty excessive. Okay, we right now do not want to run the engine because, again, I do not know where this fuel leak is, And if we've got a situation where we've got a fuel line under the vehicle or something, there's a chance it could spray on the catalytic converter or something like that. We just don't want to run the engine right now. But we definitely have a concern. What I want to do is I want to try to make a little more pronounced evidence of the fuel leak so I can find it easier, but I want to do it without running the engine. So I think what I'm going to do is we're going to go over here, and you guys know what's coming up here, don't you? We're going to go to the fuel pump relay, and I'm going to get my favorite tool, a paper clip, the same exact one you guys have seen me use for years now. I really actually do use it all the time. I'm going to take out this fuel pump relay. That is the fuel pump relay, right? Yes, it is. And what we're going to do is we're going to jumper the load side. Love GM because they put maps on the relays, so we want to jump our load side, make absolutely 100% certain and triple check that you do not jump the control side. You jump the control side, you're going to make a really long day of this. So let's double check here. All right, I want to take absolutely no chances here, so we should be hot here. We are. There's where we want to jump. And this should run the fuel pump. You can hear it run. All right, so we're just going to keep that fuel pump running. This should beef up our pressure here. Let's take a look. All right, now we're in conditions we want to be in. We've got our fuel pressure maximized here, and this will help. Hopefully we can get some drips or something like that. We can feel underneath the fuel fittings. I wanted to talk about these fuel fittings. These are going to be new to you. Oh, there it is. Look at that right there. Okay, and just in a matter of seconds, that fuel decay rate. Yeah, it's funny. You really don't need to lose a whole lot of fuel to lose a lot of pressure. I mean, there's just probably a few drops of fuel here is all. All right, if we look very closely at the line, we see we've got the metal line here that connects in. We also have over here a curved metal line that goes into the fuel rail. And then we've got our hose here with compression fittings, and we'll explain those in a little bit. The particular leak being at the compression fitting means that, unfortunately, in putting this video out, I have to air some dirty laundry because the leak here is definitely the result of a mistake I made when I was in full dismantle mode, when I was removing the cylinder head here for a repair previously. And the thing is that the compression fittings are one-time use. You do not want to disconnect the fuel line from the compression fittings. You want to disconnect it from the metal lines right here, not from where the hose is compressed in, and I just accidentally did that. When I realized my mistake, I went ahead and immediately put it back together, disconnected from the proper locations, and of course leak tested after doing the cylinder head repair. There were no leaks. Well, now we can see a year later, over a year later, this has come back to haunt me. If you disconnect at the compression fittings for whatever reason, you will have to replace the hose as well as your compression nuts as well. There's a couple different designs with these particular fittings, which are called AN fittings, by the way. AN, I believe, stands for Army and Navy, so I guess it's some kind of military standardization from the development of these. But the purpose with this is not just for looks, but your AN fittings are very high performance, withstand very, very high pressure. I want to say something like 3,000 PSI or something like that. The braided hoses, of course, look very aesthetically appealing, but there's also function with that. It, of course, adds to the pressure capacity with the hoses, which can either be Teflon or rubber. But also in the case of the rubber hoses, it really helps to prevent expansion of the hose under pressure. If you think about it, if you've got your hose and under a higher pressure the hose starts to stretch out or expand, you would actually lose some fuel pressure from that because you're widening the diameter. And so the braiding does have some functional purpose there as well. So what we need to do to fix this is we need to remove this section here, and we need to replace this hose compression fitting assembly here. With these AN fuel lines, these are always custom, so I can't just call up Fast Technologies where I got the fuel system from and say, hey, I need this particular section of hose. You make these custom, and you'll cut your hosing and put your fittings on custom for each application. You don't need any special tools or anything. It's really easy to do, so this is an opportunity to show you how to do that, because I know most of you guys probably have not seen these AN fittings before. So let me grab a wrench. All right, now obviously a lot of people, they do this for aesthetics as well, so you can put some Teflon or electrical tape around to protect the finish on your fittings. They also make special AN wrenches that are made of aluminum, like the fittings are, so that you don't scratch them or anything. I particularly don't really care about it, so I'm not too worried. I'm just going to use a regular wrench. And we're going to loosen it again from the metal lines here. Those parts we can reuse, but the compression parts, those are a one-time deal, as we have proven here. It took a year, but it did fail. While I'm doing this, one important note also on other fuel systems where this is even far more important than in this application. And that would be in GDI applications, gas direct injection. So this is a good opportunity for a really important safety thing. If you are working with a GDI system, those also are compression fittings on the lines, one-time use, and it's far more important you don't try to take a shortcut like I did by reusing a line, because in a GDI application, the pressures are far, far greater. In this particular application I'm doing, we're talking a maximum fuel pressure peak of about 70 psi or so, and we see the result from that is I got a little drip of fuel, and we get to make a video that hopefully will show you guys some new stuff out of it, and that's kind of the worst of it. In a GDI application, totally different story. With pressures up to 1500 psi, this becomes a whole different issue now. In a GDI application, if we were to reuse a component, first of all, at 1500 psi, you are going to greatly exploit any weaknesses in those fittings, so you're far more likely to have your failure, and much sooner than a year later. But that's not really the problem. The problem is that under that extreme pressure, with that failure occurring, you're not likely to get a little drip like I have. You're likely to get a dramatic aerosolization of the fuel, which is going to be extremely flammable and extremely dangerous. So had this been a GDI line, oh yeah, I would have totally replaced it. I thought I could get away with this. But if you're working with a GDI system, no ifs, ands, or buts about it. You have to replace those lines with new ones so that you don't run into a leak that can really be a different story than what we saw here. All right, let me go ahead and get that line out, and let's take a look at how this works and how we're going to make a new one. All right, again, going from the metal line here, you always want to use backup wrench on the other nut. You don't want to spin these things around and everything. One really common mistake with these is with, pretty much everything that people do is over-tightening these. You do not have to crush these down. Just, I'm not quite sure what the torque spec is, but it's just a little bit after hand tight. But don't over-tighten these. You'll actually cause more leaks by over-tightening them. All right, here's our section that we removed. Again, this is a custom thing that we have to remake, so let's bring it over to the workbench. All right, so with these AN hoses, there's actually a couple different designs, not just with the hose, but with the compression technique as well for making the connection. And with the hose, you've got a choice of either a high-strength rubber hose, which this one is actually, and you can also have a Teflon hose. And then there's also a couple of different designs for connecting the hose to the fittings, which in general for your Teflon hose, it's going to be identical to if you've ever done a simple plumbing application where you maybe ran a line to your refrigerator for an ice maker, or you ran a line to a humidifier or something. And I'll see if I can find a diagram of it if you're not familiar that I can show here. But you basically have your line, and then you'll fit a little donut over the line, a little compression washer. It's kind of a wide washer that barely snugly fits over the line. You got a compression net on one side, your threads on the other. When you put them together, the washer compresses, forms a watertight seal, in this case a fuel-tight seal. And again, those are one-time use because you're compressing that washer. This is going to use a little different technique. This is going to use kind of a funnel-shaped compression nut technique, and if I take this apart, you'll be able to see how that works. All right, and again, if you're removing a fuel line, this is not the way you would do it. So if you remove this way, you will have to replace the line, and you're going to see why very easily in a minute here. Okay, and now you can probably see how this works. You've got this nipple here that basically is going to fit into the end of the hose. We can actually just take off this compression nut here by just pulling it right off. Okay, and really a good idea to wear gloves with this because these frayed ends on the steel braid are a lot like a cactus, and they actually can stab you pretty good, so you want to be really careful working with these. There's also a trick I'll use when I cut the new hose so that we don't get this fraying like that, because you can imagine this fraying is going to make it impossible to put my compression nut back on. And we can see how this works now. We've got the compression net on this side. It's actually kind of funnel shaped. So we got the wide end here to screw on to the connection, but we also have this narrower part inside that is going to squeeze the hose tightly over this insert that goes into the hose, squeezes it tightly over that nipple, and that's how we have this compression fitting work. You can easily see now that the reason that we have the leak is because when I disconnected this, well, the inside of the hose is stretched out now. So when you reconnect your compression fitting, you don't have nearly as much compression as before, and that's why we developed the leak. All right, what we're going to do is get this other side off. We are going to replace new compression nuts and new hose. You can just buy these AN fitting hoses pretty much at any auto parts store, anywhere online. I particularly have some more from my kit that are going to match the colors and everything, so I'm going to use that. Let me go ahead and dismantle this, and I'll show you how to make the new hose. You see we've got all kinds of different shapes of adapters to do for your custom applications and everything. You can get these in all kinds of colors and stuff. Also in a variety of different sizes as well. So you start off, I believe the smallest is going to be AN2, and the number 2 is going to be about like a brake line diameter. It's going to be, you can use it for that application as a matter of fact. And then it goes up, I don't know how high. I know there's industrial applications for this, which go up to about a 4-inch inner diameter or something like that. So all kinds of sizes. And then while we're on the topic, there's also the two different flavors as well. You've got the rubber hose and the Teflon hose. So there are some differences there depending on your application. The main difference, whether you've got the Teflon or rubber hose, really depends a lot on your application, on if you're going to use E85 ethanol-based fuel or not. The PFTE, which is polyfluorotetraethylene, I know that from working in the laboratory, that is Teflon. That's going to be resistant to your E85 fuels. So if you're using any kind of E85 fuels, you do not want to use the rubber hosing. You will want to use a Teflon-based hosing. The other thing, the Teflon-based hosing has quite a bit more burst strength. I mentioned before you can go up to something like 3,000 PSI, maybe even more. That's going to be with the Teflon hosing. You're going to get approximately a third that or so with your rubber hosing. And then the final thing is that the rubber hosing is actually a little bit more flexible, a little bit easier if you need to work in tighter spaces, things like that. So some people will prefer that if they don't need that high pressure application. The Teflon's a bit more rigid. The rubber hosing is also known as CPE. I actually have no idea what that stands for, but that's going to be a rubber hosing. But again, the main thing is don't use that if you've got an E85 application. All right, what we need to do now is we have to cut our hosing to the length we desire. So I've got my old hose here that we can hold next to it. I'm just going to grab a marker. And the trick with this is, as you can see, I've still got some tape left over from the last cut. We're going to use some tape to prevent the fraying of these ends like this. These frayed ends you're never going to fit your connector on. And this is a really short piece of hose, but that's okay. As long as your two ends don't interact with each other inside the hose, then you're fine. So I've got it where it's just, there's plenty of room here. But what we do want to consider is the width of the cutting tool. So we do want to get just a little bit more to allow for the cutting tool. And the directions say to wrap duct tape around here and use a hacksaw. In my opinion, that would be the worst possible thing you could do. The right way, in my opinion, to do this is to wrap with electrical tape, because you can stretch around for a really tight fit, and also it's not as thick as the duct tape, so it's easier to fit your ends on here. The other thing, it's easier to remove without causing the frays and everything. In this application, you don't even actually have to remove the tape. And then as far as the hacksaw goes, you may not have a choice. I'm going to use an air cutting tool, but as long as you get a good, clean, very, very straight cut, it is critical to get a straight cut. And the thing is, the hacksaw, in my opinion, is just going to absolutely shred this braiding and create a whole lot of that frayed end problem. So let's pull out a little bit of hose here. We only want to wrap the tape around maybe a maximum of 2 times. All right, and this other end's already taped up pretty good. Then we need a way of securing this. I'm going to use a vise. If you use the vise, you do not want to crimp down on the hose. You just want enough that you hold it in place. Okay, of course, it goes without saying you're going to want eye protection on here, and we want to cut this straight across. All right, that worked out pretty well. We don't have too much fraying here. Now, in this application, I'm not really worried about removing the tape or anything. Our compression is going to be internal in the hose. But if you are using the Teflon with the little donut ring thing, you're going to have to pull back the braiding to expose the hose inside, and then you'll fit your washer over the end of the hose and then put it back together. I don't have to worry about it in this application. What I do have to worry about is we want to fit this end on, and so what we're going to do is kind of walk it over the end, just like that, and then you'll feel it stop, because again, it's kind of funnel shaped, so you'll feel it stop when it hits the narrow part. Then all we have to do is just thread in. All right, this is going to be perfect. Before I tighten it down all the way, just checking to make sure there's no tape obstructing the line or anything. On this design, that's pretty impossible. But also really important, I want to get some compressed air here. Blow out the line just to make absolutely sure we have no debris from the braided hosing or the rubber in there. Remember, this is after your fuel filter, so we don't want to clog up an injector or anything with the debris from cutting. I think we're good to go, so let's tighten this up. Just keep in mind, if you're working on someone else's car, they probably are going to be concerned about the aesthetics, so you will want to wrap it with some tape or maybe use those AN aluminum wrenches so you don't scratch it. You can scratch your own nuts, just don't scratch someone else's nuts. All right, it's all tightened down, and that is absolutely strong. That is not coming apart. You can see the little scratch there. These are really, really, really delicate, so if you are concerned about that, do keep that in mind. We're going to plug this back into the car and remeasure our fuel pressure. All right, this is the area of our repair, totally, completely dry. And as you know, we're not going to hold, over 50 psi for very long, but we will hold it longer than we did before, I bet. I don't smell any fuel. Let's just let this cook for about a minute or so, and I'll come back. And you can see that we're still hanging just above 40. We would have dropped from 60 to 40 in just a few seconds previously. And of course, you're not going to hold your pressure at 40. It'll probably overnight drop and hold somewhere around 20, and that gives you your starting pressure so you don't have long crank time. We are absolutely dry here. Yeah, for sure. And even in all this time here, we've only dropped about a PSI. So this is a fix. All right, I can wear my Trans Am hat again with pride. Well, hopefully you guys learned a whole bunch of new stuff that you weren't familiar with before. That's always a great thing. And if you want some more free content other than what's on this channel, just a reminder, you've got another way of doing it, and you're going to also have another way of doing it too. We've got another project coming up some of you guys know about, but we'll release that hopefully this coming weekend. But let me show how else you can get some really cool content. Just a reminder again, my partnership with Autel, where we are creating some tutorial programs for their onboard scan tool software. We've got a bunch of case studies that we don't have anywhere else. Coming up soon is going to be an engine with auto crank that keeps on cranking even after the engine starts. We've got a bunch of other cool case studies here, all using the Autel scan tool, of course. But some really, really cool case studies you won't see anywhere else. One really cool thing on this is that the videos on this are all exactly 4 minutes in length, so it's almost as if you were watching Scotty Kilmer if he knew what he was doing. To get here, just go to acufix.autel.com/home, and you will be able to search for Schrodinger's box, search for my name in the search box here. There's also lots of other content from other people. Everyone else is professional automotive technicians, so really honored to be part of this project, but there's other case studies and things that you can look at. But please do come visit here, and please also click to follow me, and you'll get notified when I post new material here. I am aware not all countries have access to this website, and I am going to work out something with the guys at Autel where we will make that content available to you guys separately. I'll probably put it on my paid channel for free or something for you guys. Speaking of which, don't forget to visit my website at www.schrodingersboxqm.com for quantum mechanics. First of all, anybody can get 15% off the AutoWine Pro smoke machines that I featured in previous videos. But most importantly, we have so much content, hundreds of hours of videos, and this is where the best material is. This is step-by-step tutorials to make you capable of doing all electrical and engine performance diagnostics with your scan tool, and how to read wire diagrams and things. We've been doing a whole bunch of work lately on VVT diagnosis and differentiating whether you've got solenoid issues, phasor issues, or other mechanical issues. Every video is going to show you how to do all kinds of ways of diagnosis using advanced tools like an oscilloscope or just your basic test light and DVOM. Lots of wire diagram tutorials, lots of the best, most fascinating case studies as well, and we go step by step through them, looking at the wire diagrams, reading factory information and interpreting it. Oh man, I don't want to relive this. This is where my Trans Am blew up a while ago. But there's just hundreds and hundreds and hundreds of hours of material here. Only $3.49 a month. You will have a blast if you come and visit here. And finally, as indicated, we also have another free content resource coming up pretty soon. I'm not going to spill the beans on it quite yet, but we're hoping to release very soon. You guys will be very excited to see this, so definitely stay tuned here on Schrodinger's Box Do-It-Yourself Advanced Auto Repair channel, and we will see you next time. Ooh.